Hello and welcome back to my Commodore 64 Demos Peak video series. In this video, I'm going to have a look at a couple of parts of Multiverse by Nah Kolor. I was tagged on a Twitter thread about this demo and how a specific part was working, so let's have a look at it. So yes, if you like these kind of technical deep dive videos, then please do consider liking or subscribing to this channel, or sending me a super thanks. They are always very much appreciated. There are several really great effects in this demo, but the main effect that I was tagged to look at is related to this spinning shape here. Now this looks like a regular multicolored text screen, but obviously it looks like it's double buffering, and if we look at the memory view here, we can see that it's sequentially reading through memory, where it was, and it was sequentially reading through as it was spinning this object. And again, this image here, we can see that it's sequentially reading through memory, and this strongly indicates that it is basically an animation, what we call an animation, where sequential frames are just rapidly read through memory and then displayed on the screen. We have this vertical sprite bar here, and if we have a look at the detailed VIT debugger, we can actually see that we've got multiplex sprites for the sprite bar that moves across. But basically, this part of the demo with these rotating geometric shapes are basically displaying a character text screen or multicolor text screen animation of different frames. Now it's interesting to note that most of these animations seem to be using one character set. And then we get to this part. This is the specific part that I was asked about how it was working. And in the C64 Debug GUI, we can see that there are no sprites, but we can see that there seem to be, in that memory view there seem to be several sequential areas of memory being read for what looks like the number of spiky ball things falling down the screen. So let's have a look at this in ICU64 in a little bit more detail. Entering this demo part, when the stars come on the screen, we can see that there's a lot of decompression going on. And when this spiky ball thing comes in the screen and it starts animating and showing its animation frames, we can see that we get these sequential reads through the memory, and then the memory writes as the yellow bar at the bottom into the screens. Now that we've got two double buffered screens here, if we view the character set and we go back to that demo part, the character set for this animating spiky ball is actually constant. This means that the data that's being copied from the memory are just different characters, the text screen content, rather than the character set content. So this actually means that this spiky ball is able to show all of these animation frames just by updating the characters, the textual content, if you like, of the text screen. We can see that quite clearly there, that different characters are being used when I use the wrong character set. Now this is important because once we know that we can actually display a rather large spiky ball thing with different characters, we also know that this effect uses a constant or static character set. It's just that the characters on the screen are being updated. And if I advance each frame in the emulator, we can see it actually takes about 3 full frames to copy or decompress the information from main memory into each double buffered character set or text screen. Now, this is actually really useful information because now we know that when we see these complex rotating objects here, that we can safely assume, and we can also verify that in the debug view there, that we're just seeing character arrangements being copied into a screen with a basically static character set for each object. Let's save the snapshot here using the save snapshot functionality in the Vice emulator, This Vice emulator version has, of course, been connected to ICU64 so that we're getting all of this extra debug information. And I have a video about the tools that I use during these videos, and I'll try and remember to put a link to that in the section below. So we get to the main part, which are these multiple spiky balls that zoom in and out and rotate around as they fall down the screen. And if we have a look at the debug text view there, we can just see that it's just two double buffered text screens with what look like separate areas being copied. Now, if we advance the frame, we can actually see that several of these get drawn per frame, and it's running at about, I think, 3 frames for each total frame update as well. But we can see from the memory debug view now that these green reads here indicate that each frame of the spiky ball rotation with its zoom level, if you like, is just copying from different areas in the screen. So let's put a watch point so that we can actually trap into the routine. Now this routine here looks like it's just clearing, it's loading the accumulator, storing it within a semi-unrolled loop, but it's basically still using an index store to clear the screen, right? So we'll hop out of this routine and we'll go back to the parent routine and we'll see if we can spot anything interesting to look at. So I'm just using the step over functionality now in the Vice integrated monitor, this nice version of Vice that has the better version of the monitor. And we can see here that if I go and step over that, it seems to read a bunch of bytes, but it doesn't seem to have actually drawn anything on the screen, on the cleared double buffered screen there. So let's see what this code now does. It seems to loop around a little bit. It's updating some pointers. It's jumping back again. Okay, let's jump. Oh, there we go. It's drawn a partial spiky rotating ball thing there in the double buffered screen. That's interesting. And that's JSR 279C there. And it's updated the next one. Looking at this demo effect so far, it seems to be what I think is a well-constructed character set with various animation frames for each rotation of the object and scale and stuff like that. Just using this nicely constructed character set. It may even be an automatically created character set by some tool somewhere. It's not really that easy to find out if it's tool generated or generated by hand, but either way, it's a single character set with nicely animated character-based graphics animations. So if we step over this again, we'll expect to see another one drawn, I think. This X, Y, and A looks like it could be, looking at this, maybe A is the animation frame, and X and Y are X and Y positions, perhaps. We can, of course, test this out, I think, by, let's say, for example, override the value of A that comes into this JSR 279C there. So we can assemble some extra code, and because it's 2 bytes already, we can just assemble an immediate load accumulator, I think, at 21C2. And we can just assemble that as, well, we can either put the opcode in for load accumulator immediate, which is A9, or we can use the assemble command in the monitor, and that's what I think we'll do, is that we'll just load accumulator with the value of 1 directly, and we'll just exit, and there we go. We now have the same animation frame just scrolling down the screen. So obviously that routine there just copies across the relevant animation frame at the X and the Y position that it's told to, and then you get all of that. So you don't get the animating, twisting, scaling graphical object appearing in different places on the screen. You just get all of the animation object with the same frame appearing on the screen and scrolling down. So that's how that routine works. Let's look at the memory view for some of the other effects in this demo, because actually some of the demo effects generate some really interesting memory view patterns, and I want to go into this in more detail. So actually this is a flip disk screen, and the sample is just playing back from memory by the looks of that, so we can see just the scan going through memory there. and the music in the background is just a repeating sample. This rather lovely effect, which is coming on soon, there we go, you can see from the memory view there that we seem to have maybe one buffer which is 128 pixels wide and maybe 128 pixels deep, but it's side by side, and the memory view is aligned to 256 bytes horizontally, so that's what kind of indicates to me that it's 128 pixels horizontally, because we've got the left and right views there. Or maybe it's just reading, but basically you can see that the pixels highlighted in the memory view there are going to translate to the rectangular pixels that are visible on the effect. This demo part as well has some interesting memory read patterns there. So the green memory read patterns there, that indicates which pixels are being translated into the view that you can see on screen. So there's obviously some kind of speed code or lookup table. The speed code there I think is maybe running in the blue area in the top of the screen memory view or event viewer there. So the X and Y position pixels that are plotted on the screen are read from the green memory event view display there. This colored bar effect, you can see the memory read patterns going on there in the memory view, with the wavy line patterns which seem to correspond to the wavy patterns that are visible in the color bar effect actually on the screen. This part here, which shows a square or rectangular view on the Commodore 64, you can see the pixels that are being sampled from a very large, what looks like 256 wide, maybe 128 wide, or maybe smaller, 196 bytes or something like that maybe. But the virtual buffer, which is held in the memory, you can see the pattern of reads, which translates to the square pattern that's drawn on the screen. Now this yellow bar that's right going across is basically fading out the data, and the data from the effect is still reading the faded out values, which produces that nice wipe effect. It was just wiping through the whole of memory. And this part here again shows you how a spherical or bumpy blob in the middle of the screen translates to spherical reads throughout a buffer held in memory, and you can deduce from this that the buffer is 128 pixels wide, or entries wide anyway. I would really recommend using ICU64 or C64 Debug GUI to look at the debug memory access patterns, because sometimes these demos, when they have complicated graphical effects, can really show interesting, complex memory read and write access patterns, which give you a good hint or a relatively good understanding of how some of the effects actually work, that they are using a very large amount of lookup table memory, but they're just basically translating from what look like distorted or sparse reads from a great big table somewhere that scroll around, and then translating that into consecutive horizontal and vertical pixel writes which are actually on the screen. So using this, you can then try and apply the same kind of memory lookup patterns to generate animations or distortions of graphical data actually in your own demos too. It's really quite a useful way of trying to delve into how these demos work. So I think that's all that I wanted to cover on this video. Thank you very much for watching, and if you like this kind of Commodore 64 retro games on demos, technical deep dives, then please do consider liking or subscribing to my channel, and I really hope to catch you around next time. Have a great day, evening or night, wherever you are.